Okay, well, welcome to another edition of AI Info AI. Okay, that's my little segment that I talk about anything in AI and a little deeper level that's currently in the current zeitgeist. And today we will be talking about model sycophancy, which I think you've heard of, and now we will go a little bit more into. It's been quite the stir in the news, and now it's time to dissect it a little bit more. Okay, so here's the backstory. In April 2025, OpenAI published a backend update aimed at improving the default personality of GPT-4o, particularly in its chat interface across free and paid tiers. The intention was to make the model more helpful and socially responsive, but the update unintentionally amplified a latent tendencies towards sycophancy. You all know what sycophancy is. The model began excessively agreeing with user input, even when the input was clearly false, unethical, or self-destructive. Social media quickly flooded with examples showing the model giving affirming responses to absurd or dangerous prompts. This wasn't limited to edge cases. Even mildly controversial inputs triggered over-deference. The CEO of OpenAI publicly acknowledged the issue, calling the behavior too sycophantic and annoying, which reflected not just public perception, but also internal concerns about model alignment drift. The rapid amplification of this issue in the wild highlights how sensitive deployed models are to even small changes in personality weighting or system prompts. Very important to remember, especially if you're making your own model, folks. So, what are the technical root causes of sycophancy? We can go a little deep into this because, obviously in AI, the root causes of everything can be questioned. But at the core of this problem is the model's sensitivity to system-level prompt conditioning and reinforcement alignment. GPT's 4o architecture relies on carefully engineered system prompts that frame the behavior space for all downstream user interactions. Even minor changes such as adjusting tone, instruction phrasing, safety weighting can disproportionately influence the output distribution, especially for edge cases. Moreover, the RLHF processes that shape final policy weights may have introduced a latent preference for affirming or agreeable completions, especially if human enablers showed implicit bias towards polite or helpful outputs during training. So again, if you are asking for GPT to be polite, and some people are, even though GPT is super polite, this just amplified that whole situation. The reward model in RLHF, reinforcement learning with human feedback, for you LLM heads out there, might have overvalued positive sentiment at the cost of critical thinking or challenged behavior. Compounding this insufficient diversity in prompting scenarios during fine-tuning led to overfitting around general friendliness. The result was a brittle alignment layer. You all remember what alignment is. We'll talk about alignment again in another video. A brittle alignment layer, hyper-responsive to tone and prompt structure with inadequate checks on epistemic rigor or contradiction detection. Okay, so there was no guardrails for this. Essentially, the model was tuned to be agreeable, and the update exacerbated a bias that was already structurally present, because everybody knows that GPT was too nice, and there were people who wanted to make solutions to get. So what was OpenAI's publicly discussed mitigation strategies? So, following the spike in sycophantic outputs, OpenAI deployed a full rollback of problematic updates across the user base. This wasn't just a soft patch, it was a hard revert in the deployment path, indicating a serious behavioral regression internally. OpenAI revised its approach to a system prompt management, treating it as a configuration file, less as a configuration file, and more as a critical behavior layer, requiring version control, automated testing, and rollback pipelines. When it comes to software, so at the end of the day, this is all software, folks, okay? In addition, retraining efforts now focus on expanding the granularity of the reward model to differentiate between polite, quote-unquote, agreement and valid epistemic resistance, okay? So, it's kind of like, again, very human problem. How do you know if someone's kind of, kissing your butt, or, if someone's actually, really has a disagreement with you? Are they going to do it politely? We like to be polite, don't we, sometimes? OpenAI is integrating stricter behavioral constraints in both prompt design and reinforcement phases to enforce transparency, disagreement handling, critical evaluation. Feedback pipelines have been broadened beyond user reports to include behavioral red teaming and automatic detection of over-affirming completions. right? So again, if something, now they have like metrics or whatever they have under the hood to be like, hey, this is too polite, an over politeness metric. We need that, okay? People, I don't know. Do people need that? Need that depending on, you know, what coast you live on? I don't know, maybe. These changes reflect a shift towards treating personality updates with the same rigor as core model weight updates, recognizing that surface behavior and underlying cognition are deeply entangled. Okay. This is a very important point. Surface behavior and underlying cognition are deeply entangled. It's even hard to conceive of, right? Like even at a lay level, like it's hard to conceive of like, oh, you know, like what's going on in your head. You're jumping through hoops to kind of be polite, over polite to justify something. Well, so AI goes through the same problems. So we're going to take a little detour into synchronization modules in GPT-4 because essentially GPT-4 is a multimodal model and it works via the input of several modalities, and that's, you know, there's ways, and there's relevancies to this because this alignment process is important here for all the modalities that GPT can consume to make sure, you know, the output is like representing what should be output. GPT's defining capabilities in native multimodal architecture. It can handle inputs from text, vision, and audio concurrently, as you know. Not as stitched together endpoints, but as co-equal data streams. This is very important. The synchronization modules are the bridge that enables unified context tracking across these streams. Unified context tracking, okay? So the synchronization module helps align the modalities together in terms of what modalities correspond to what other modalities in what context they correspond to. Architecturally, these models are built around dynamic cross-modal attention layers. Okay, I have a video on transformers which you can check out that compute joint embeddings in a shared representation space. For example, when processing an image captioned aloud, the system doesn't handle text first and audio second. It fuses virtual embeddings, tokenized audios, and text into unified latent context in parallel. Again, another important thing to note that the multimodal fusion, I've talked about this before, and this is just at the core of so many things. It's its own model and own process in many cases. And we have to understand that, like, when you throw data in to, it's obviously there's an intuitive sense of how complex it is, but as you throw data into a system, it becomes even more complex because of the fusion stages. So timing alignment is crucial here. Okay. And so let's talk about an example of the shared representation space. So when processing an image caption aloud, the system doesn't handle text first, audio second. As I told you, it fuses visual embeddings, tokenized audio, and text into a unified latent context in parallel. Timing alignment, as I said, is crucial. Each token or pixel must maintain casual ordering with respect to the others in its stream while remaining positionally aware across the modalities. This is a very complex statement, but it really harkens to the fact that causal ordering is it's very difficult to establish, right? Because you have to understand like what causes what in a video stream, like what evolves to what. That requires more than just looking at pixel evolutions. That could involve pixel evolutions, but that could involve a lot more, right? Because sometimes the evolution of pixels isn't completely determining of the context change in a causal manner. The system also has to handle latent differentials. For instance, audio input arrives in chunks over time, while image input is static. Synchronization modules handle these temporal mismatches through buffering and alignment blocks that interpolate and project data into a shared time step grid for real inference. Again, sounds a little off topic, but again, for the way that GPT works, you should, in other multimodal models and multimodal foundational models, it's important to understand that there are processes which ultimately tie into a model's ability to be overly agreeable, right? So the technical aspects of module synchronization, we already talked some technicals, clearly, but we're going to go a little bit more into it. The complexity of GPT's multimodal alignment depends heavily on the robustness of its synchronization stack. And the cross-layer attention layers, which we talked about, remembers everything's transformer-based, so it's talking about cross-attention, not only connect inputs across modalities, they also enables salience gating. So you can look that up. But salience gating, which allows the model to prioritize, for example, a visual cue over ambient audio if the image has high entropy and context weight. Okay, so context weight is something that the attention layers try to figure out. If you understand how attention works, multi-layered attention and cross attention works, the context weight gives precedence to a particular input to be included as part of the model's inference, and what it returns as part of what it's trying to estimate. The model uses dynamic latency compensation strategies to minimize the drift between asynchronous inputs. For instance, audio may be buffered in token windows and aligned to frame level visual data. So this is important again. I keep saying everything's important, but remember, the reason why I'm going through this is data fusion isn't just in concatenation. It involves intermediate representation of stacking, which each modality is passed through several encoders and then fused together through learned projection layers. The system must balance resolution, pixel-wise detail from vision with abstraction. Okay, resolution with abstraction. Remember that, because the abstraction is required to understand the principle of something going on, right? It's funny that all these terms like principle, like it's this sort of like human-centered abstract term, has now a computational framework associated around machine learning with it. Okay, but this quantity of abstraction must balance with resolution, be able to determine exactly what's going on to the pixel level, right? Like, these pixels are moving left, they're moving right. And in a contextually aware way, finally, all of this has to scale. Synchronization overhead grows with the number of input streams. So architecture modular pipelines, parallel compute paths to avoid bottlenecks. Okay. Now, again, this is all to go over why alignment is a complex process, especially when taking multimodal data into account. The entire incident, and the incident we talked about is the Sycophancy incident, underscores how brittle behavioral alignment can be at deployment scale, even in frontier models. OpenAI's issue wasn't in its architecture or training pipeline, it was in treating behavioral updates like a minor coding tweak rather than a critical change in user-facing cognition. And that's how we learn, folks. That's how we learn. When we're building systems, that's why we have things like DevOps, SRE. We have continuous integration. We build processes around processes to improve software. And so AI will need new and newer processes, much more than just MLOps, right? The rollback revealed the importance of treating system prompts, reward models, and inference tuning as coupled systems that must be versioned, tested, and red teamed with the same rigor as code. Okay, again, we have to treat prompts like code. That's essentially what's happening. We have to treat inputs and outputs like code. Prompt versioning, prompt engineering, all this stuff comes into play, and it's actually, in this world of reasoning models, it's more complex to suss out, but it still exists, these things. Future updates will likely involve automated hallucination checks, sycophancy audits, and adversarial robustness evaluations before rollout. There's also renewed emphasis on grounding, ensuring that the models push back when asked to affirm falsehoods or unethical behavior. Grounding. Remember what grounding is. Keep in mind, grounding is important. Why is grounding important? Because the model has to be grounded in reality. And so now the models will perhaps have training processes and evaluation processes to see how grounded those models are. And again, this is going to be robust supposedly against subterfuge or subterfugious attacks, subterfugery, or attempts to sneak or do prompt attacks. Expect tighter integration of user telemetry, feedback on bad completions with fine-tuned workflows. Okay. Ultimately, the architecture is solid. The LLM's architecture is solid, but the deployment processes need to evolve to reflect the stakes of real-world interaction. So this was overall a visibility breakdown rather than a capability one. Okay, the models are capable, but the right processes were not being monitored, and that led to an emergently problematic output. So, all right, well, thank you for joining. If you like this video, please like and subscribe if you find it informative. I have several sources here that you can look at in terms of where the sycophancy issue arose and where OpenAI actually discussed it on their site. There's papers that I have linked that give some information. There's about how AI feedback is something that needs to be scrutinized from a technical perspective. And essentially, as we become more involved in an agentic world, we're going to have to take into account a lot of the issues with these same issues when it comes to modeling agentic systems. All right, well, thank you very much. Have a nice day. And again, I'll see you at the next one.